So very good evening to all of you. Welcome back. Okay, thank you so much for, but let's continue today. So we did a couple of things in the past sessions. We understood the connectivity and we got a little understanding of data structures in the previous session where we spoke about the primary data file, the secondary data file. We spoke about the significance of the primary data file in terms of storing all the system tables and why we need to basically keep all of that, our user tables away from the primary data file. So in this way, we basically ensure that the system tables are optimally used and thereby improves performance. So today we're going to continue with a little more on data structures. I will give you a few more demos and most probably try and elaborate a little more on what can be done in terms of getting things good and running. My system is just started, so it's going to be a little cold. I'm going to share my screen in a second and we'll continue with demonstrations like earlier. Just let me know once that screen is visible. Management Studio is opening up. And before we go into the that machine, let me basically open up a PowerPoint slide here. And try and see if I can get you some pictures of the concept which we're going to actually work today. We're going to be continuing with data structures. We're going to be understanding how data structures work and how we can basically, how can we use those data structures to optimize our database and the queries that run on that database. So that's what we are basically looking at. So this is the physical design. I'm just looking for that deck. Just give me one more second. Oh, that's okay. I was not able to find that. Let me go ahead and use a whiteboard itself. Okay. So here is my whiteboard. I hope that's visible. Okay. Now, SQL Server, we spoke about files. Yesterday, we understood in the last session, we understood the MDF, which is the primary data file. We also understood that this file is now going to store all the system tables in it. We also understood the secondary data file, which is, we recommend you use the secondary to store all your user database and tables. Now that is what we did. That's what we understood. And we understood why this will improve performance because most of your system tables are predominantly going to be used across all queries. So putting your system tables on a dedicated this now every file. Now this by far is the most important concept for you to understand query optimization because 90% of your query optimization depends on your understanding of these data structures and your visualization of these data structures. So I would say this is a very important session in terms of us actually trying to basically look at a query and say what to do to improve its performance. These units, which we are talking about, logical units, are called pages. Each page is 8 KB in size. Out of this 8 KB of this page, some space goes away for what is called the page header. Some space goes away for what is called the page footer. So you have some space going away on every page for the page header, some space going away for the page footer, and what is remaining for you to use is 8060 bytes. So when you want to store data, data is always stored on a page. A page is a logical unit of your data file. And now how many pages can you have on a data file? Naturally, that depends on what is the size of your file. So when you're creating a database, you can say, I want this to be a 10 MB. I want the size to be 10 MB. So you just pick up 10 MB divided by 8 KB, and you will get basically the number of pages that is made up of. And your size of a file will always round up to multiples of 8 KB, because you cannot have half a page or a quarter page or a 10% of a page. Either you have a full page or you don't have a full page. So whenever you're setting a file size, you can remember that it will always be rounded up to multiples of 8. Okay, 8 KB. Okay, because everything has to be broken down into a page inside that file. Now, this 8060 bytes is the only data that you have, which allows you to basically store data on a page. Now, why is this page concept important to us? Why do we need to talk about this? Why is it basically something that is critical for us? Now, as far as SQL Server is concerned, or whenever you're trying to get data out of your tables, now you look at it as a table, you say, I'm saying select star from table name. But as far as the optimizer is concerned and the access of these data is concerned, it is all about finding the pages on which this table is located and reading the data from those pages. This is what we basically call IOPS. So when you talk about an input-output operation in SQL Server, we are talking about a read of a page or a write to a page or a hit on a page. Okay, all of this is called an input-output operation. In fact, to actually say that, I mean, you might read 10 rows, but that does not mean your IOPS are 10. Your IOPS will be 10 if you had to access 10 pages. Your IOPS will be 10 if you had to access the same page 10 times. So if you had to, in a single query, you had to hit the same page 10 times because there were 10 different rows that you had to read from it. Your IOPS will be counted as 10. So when we talk about optimizing queries, there are two things that we optimize. One is the logical operation and one is the IOPS, the IOPS will be simply reducing the number of pages that a query is touching. It's as simple as that. So this page, like I said, becomes a very important aspect. The first thing that I would like to talk about in terms of page before we go more in depth into page structures is to basically understand that what is the size space available on a page? It is 8060 bytes. And the concept which we have to understand here, which is very important again, by default, SQL Server does not allow you to store a row across pages. I'll repeat, you cannot store a row across pages. So if you had a single row in a table, which was greater than 8060 bytes, you will not be able to store it in SQL Server because in SQL Server, a row has to fit on a single page. It cannot split it across multiple pages. So very important concept. Okay. And just to demonstrate this concept to you, what I'm going to do is I'm going to switch back to my SQL Server machine here. I'm going to connect to my database engine, and I do have a sample database which I created the other day for you, DemoDB. I'm going to use the same DemoDB to demonstrate to you this concept that SQL Server cannot basically split rows across pages. So I say create table. I'll call this table X. I'll put in a column 1, let's say integer. I'll put in a column 2, and I will say this is char 5000. I'll put in a column 3, and I'll say this is char 5002. Now, if you're looking at the size of this particular row, after I create this table, what will be the row size? I have two columns which are fixed characters. They've got 5,000, 5,000. That's around 10,000 char. That's the 5,000 plus 5,000. Then I've got a 4 bytes integer. Plus there will be a 4 bytes row ID, which is basically added to every row that I create in SQL Server. So I'm going to be looking at 10,008 as the row size here. Now, this is very contradictory to what I told you earlier. I just told you a few seconds ago that SQL Server cannot basically split a row across pages. And here we see a row is 10,008 when a page can only store 8060 bytes of data. And here we basically got this at 10,008 bytes. So what's going to happen? How is this going to actually work? Now, when I run this command, I think I've already got a table X. Let me change that to table Y. So when I run this command and create this table, you will see an error message. Creating or altering table Y failed because the minimum row size would be 1011. That's what I basically calculated here for you. Including 7 bytes internal overhead. So sorry, this is not a 4 bytes internal overhead. That's a 7 bytes internal overhead. So that's 11 bytes, 1011. That's going to be the row size, including the 7 bytes internal overhead. This exceeds the maximum allowable table row size of 8060 bytes. Now you can understand why that error is there. Because SQL Server does not have this ability to split these rows across pages. It has to store this row on a single page. However, if I made these varchar, this guy would have no objection. Now, when I go and try to create table Y, he creates them successfully. Now, why does he do this when you create varchar is because he does not believe that you're actually going to utilize the size. This is a varying data type. With char, this was fixed. You are always going to use 10,011. Now, your insert will be a problem. Unfortunately, I'm not going to demonstrate that, but I'm going to just explain it to you. When you insert now a value 1, into tables, these tables. So I insert into column 1, column 2, column 3. If the insert record size is greater than 8060 bytes, the insert will fail. You will not be able to basically make the insert. However, this rule is not applied when you're using blobs, when you're using binary large objects. When we talk about blobs, we're talking about blob data types, okay, where you're basically looking like things at varchar max, which is a blob data type, actually speaking, or text or image, which is now obsolete. We recommend not to use text or image anymore, to use the varchar max, because when you use that, it is treated as a binary large object. Now, what do I mean it's treated as a binary large object? Now, when we talk about a binary large object, right, we just clear this canvas again, and let's basically look at this as a page. Some space gone for the header, some space gone for the footer. What you have left is 8060 bytes. And let's say now you had a row here, which basically had a varchar max. So you were basically now creating a table which had an ID, name, and basically description and content. And this, let's say, was a very large row, varchar, and it could store maybe even 1 GB of data. That's how much data you could put into a single column, into a single row. Maybe you can put a lot of data here into content, maybe, or one of these. So you use the varchar max data type here, where your data could go into MBs or even GBs. Now, how does this work? Now, this particular column will not be treated as a normal row. This will be treated as a blob. What is the meaning of a blob? Now, when I say blob, when data is being stored for this row on this page, the ID will get stored. For example, let's say we have an ID of 5. The name, let's say, is basically ABC. So you'll have ABC stored. I'm just trying to help you visualize this. So, and let's say you had a description which basically said blah, 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 something. So you had the description which will get stored. Now, instead of storing this huge column data, which is a blob here, what this guy will do is he will put in a pointer to another page. Let's say this is page number 10. This page number 10 is a pointer to another page, which again is a similar page, which can, as a header, which has a footer, can store only 8060 bytes. It will try to store the data now for this column on this page. Now, if this page is not enough, this page further will get split into 2 pages below. This is why it's called binary, because it uses a binary tree. And this page in turn will again get split further in case this space was not enough. So in this way, what happens is when you're trying to read data for this particular column, this will lead it to page 10, which is the root page of your binary tree. And it will read the data from here. And if that it still has more data, you'll have pointers now taking it to, let's say, page 11 and then page 12. And again, this will take it to further pages, maybe 13 and page 14 and page 15 and page 16. So this is your binary structure. So blobs, this rule is not there. Okay. As simple as that. Now, important or interesting is why you can basically be conscious of every it on a page when you're trying to reach data. So one of the primary design goals of a designer who's designing the database and a developer who's creating the queries, one of the primary goals is how am I going to execute this query and touch the least amount of pages, because that is your physical optimization. You're talking about reducing the number of pages that you basically touch when you're reading a query. The lesser pages you touch, the more faster your query is going to perform. The whole idea of indexing is about basically reducing pages, reducing the IOPS. And this could be the most powerful way to optimize a query. So a designer who's creating these tables, creating these data types, creating these columns, he needs to be conscious about it. A developer who's writing those queries needs to be conscious about it. And as we progress through these sessions, you will see how as you're writing that query, you'll start visualizing now the page access. You'll start counting what are the number of pages your query has been touching. You'll start asking yourself the question, what can I do to reduce these number of pages? Can I touch lesser pages and still get the same output? And that's for you, your starting of thinking as a query optimizer, where you start thinking how to optimize. Now, one of the easiest ways of ensuring that you touch the least amount of pages is to basically ensure that you store as many rows possible within 8060 bytes. Because the more rows you can store on a page, the lesser will be your total number of pages. And the lesser your total number of pages, the lesser pages you have to access. That's going to be the simplest concept for a designer. So when you're creating these data types, if I created a column called ID, a good question would be is, should this be an integer? Should this be a big int? Should this be a small int? Should this be a tiny int? Guys, this is a very basic principle, most probably, which we all learned in RDBMS concepts. Use the smallest possible data type. Now, by using smaller data types, you basically make the row smaller. When you make the row smaller, the more rows fits within 8060 bytes. When more rows fits on a page, the lesser will be the total number of pages. The lesser the total number of pages, the lesser reads you need to do on these pages. Your IOPS will automatically reduce. Now, one of the habits which I've seen recently, that most people who basically use character and string columns, by default, basically start using the nvarchar and nchar, okay, on each of those columns. Now, this is something which I would like you to be conscious about, and most probably this nchar and nvarchar. In some cases, the designer has been conscious about what he's doing, knew why he was using a Unicode data type there and not a non-Unicode data type. In lots of cases, this has just become an habit because most of the Microsoft samples that come with AdventureWorks have nchar and nvarchar basically as their data types. So people just go ahead and use them. Now, what is important to understand is if you have an nchar 5, that basically is going to store 5 characters. But if you have an nchar 5, that is going to be 10. So you're doubling your size. Let me just show you this right now. I'll show you this with a demo. I'll just go back to char right now. I'll go ahead and call this table Z. So I've got create table Z. I've got 5,000 and 11 there. So I can basically put 3,000 here. So this is 8,011. Now this is creatable, right? So when I create this table called Z right now, you should get no errors, no problem, because my total row size here is only 8,011. Right, including the 7 bytes overhead. Right now, what happened is our 2 columns, char columns is basically 8,000, 4 bytes for the integer data type, 7 bytes overhead. And here we've just got 8,011, which means we are within our 8060 byte limit. Now, let me change this table to ZA. And instead of carrier, I'm going to basically say nchar. So now what I'm going to do is I'm going to basically use a Unicode data type to create this table called ZA. Now when I execute this, you will see I've got an error. It says the 5,000 given to the parameter column 2 exceeds the maximum allowed. The maximum allowed in NCAR is only 4,000. So great. Let me reduce that to 4,000 right now. So I've got 4,000 plus 3,000 is 8,000, 8,004. Now this most probably is going to increase my size. So what I'll do is let me change this to 3,000. Now, do you think this is good? 3,000 plus 3,000 is 6,000, 4 bytes the integer data type. So you're more or less basically looking at 6,000, sorry, plus 4 bytes for your integer, plus 7 bytes overhead. So you're looking at 6,011 bytes, right? Out of which you actually got 8060 bytes as your total row size. So this seems good. Seems no reason why this should not be created. But when I execute this right now, I select this and execute it and click on it, and you get the same problem again here. It says creating an alternating table that it failed because the minimum row size is 12,011. Now you'll be wondering why 12,011? We just made a calculation here of 6,011. But actually speaking, when you use Unicode, this is actually into 2 because it doubles the size. Guys, this itself, I could tell you, could basically improve a lot of performance. Why do you need a Unicode data type? No, Unicode data type is when the column that you are basically storing data in is using a very, very wide character set. Because Unicode, since it takes 2 bytes for every character, it has the 16 bits, 16 zeros and ones as a combination, thereby allowing you to support multilingual. You will be able to store French characters, Chinese characters, Sanskrit characters, English characters, Latin characters, all of this most probably. So it will recognize multiple keyboards, multiple characters from a keyboard. So it gives you the widest possible character set. But honestly, is this what you require? If all you're storing is basically normal English in your data, and you're not using too many special characters except the basic ones that's available on the US keyboard, then you don't need a Unicode data type. So why use the Unicode? Actually, guys, you can reduce storage costs by 50%. You can improve performance by basically drastically, because you'll be reducing your total page counts by half if you just basically remove all the NCHARs and convert them to just normal characters, all the NVARCHARs and convert them into normal VARCHARs, and not use Unicode. So please check in your databases today as you go back and see how many Unicode data types you're using and whether you really need them. Okay, have you evaluated them? Have you really decided that you need a Unicode data type, or that was something which you just basically wrote in when creating the table because you've seen the AdventureWorks sample having a Unicode data types everywhere? All of this will go a long way. I know we are still not talking about query optimization, but guys, it's not all about the query always. So before we come there, it's always good to understand some basic stuff. And this is all basic stuff that we are actually covering. Please try and basically understand whether you really need Unicode data types. So 2 recommendations, one which I gave you earlier, okay, consider the use of varying data. So when I say varying data, when do you use char? When do you use varchar? Okay, please consider them. When you see something in your database, which is varchar 5, you know this is a mistake. Why is this a mistake? Because you are basically giving the system an override for the varchar, because now it does not know the length of this column in advance. Every row, this column could have this needs an extra override when reading the data, when updating the data, as well as inserting the data. Okay, because now every row has to keep track as to what is the size of this column 2, because this column 2 could be 1 byte, it could be 2 bytes, it could be 3 bytes, and it could vary from. So when you use varying characters, by default, you are basically giving extra work to your CPU, because there is an overhead in order to read, write, or update this data. So when you say varchar 5, I'm definitely saying mistake, because you're not going to save anything here. Let's say most of the columns were 2 bytes. You might think I'm saving 3 bytes, but then when you look at the overhead of the varchar, it's not worth it. So usually a varchar is good only if it is 15 and above. Only if it is 15 and above. Less than 15, a varchar is bad. Not recommended. Will be considered to be a mistake. And even if it is 15 and above, it is good to understand your data. Let's say I had a varchar 50. Let's say I had a varchar 50. Now, some of you might say, that's great. You just gave us recommendation that 15 and above, it's good to basically say varchar and not use char. This seems idle. This seems great. This seems the right thing to do. And let's say I analyze the data inside this column, and there are 10,000 records or 20,000 records inside this column, in the rows in this column. And in this 20,000 records, let's understand, let's consider that 99% of them are of length 48. So guys, if 99% of your rows or even 90% of your rows are going to be of a length of 45 or 48 or greater than 45, it means you are not saving much space at all making this a varchar. It would have been far better off just saying char 50, because the system would not have had the overhead of basically updating this. I know, guys, this is super fast. Usually it happens at set speed that you don't even notice that this is basically happening, but it's happening. And as you basically look at multiple things happening, and when you're looking at it in concurrency, this all becomes challenges for your performance. And they're all simple things which could have most probably avoided giving the system more work. Because as a developer, when you're developing this stuff, when you're designing this stuff, you're most probably running one query on it, two queries on it, like I'm doing right now. But as you have 25 million people basically trying to update this value, that's 25 million overheads which you've given the system when you didn't have to. Okay. So optimizing starts with basically design, starts with you basically, and some of these things which I'm giving you today are things which you can actually take back and implement without much stress, without much of an hassle. You should be able to do this. Yeah, it's going to take a little bit of change, a little bit of effort, but it's not something which is unchangeable. It's not something which is a disruptive change. It's not something which will basically be impossible to basically make this change without some amount of effort put in order to make these changes. So these are the two recommendations I would basically talk about today. One, consider the use of varchar. Two, ensure you use the smallest possible data type. And three, which I am assuming you've already understood, okay, do you really need Unicode? Okay, so those are the three things which I would basically leave you with today as a part of what you need to consider. And I hope to see you guys going and rolling out some of the stuff in your environments, maybe if not in your production, at least in your development, checking out the differences, doing some performance testing, coming back to me and telling me whether you're excited and you see what your learning is being implemented. And we'll come back again tomorrow. But before we close this session, like always, I would love to take questions from you guys. Anyone has any questions, please share.
Actually, suppose my database want to support the multilingual data, like some maybe Arabic maybe accept sometime it may accept English in the same column, or it may be French. That time can I use the nvarchar, no? Or still I cannot use the normal varchar?
Absolutely, you're totally right, Sundar. You got that understanding right, because in fact that's the only use case for you to use nvarchar, Unicode, because then you're supporting a lot of character sets. You might have some Arabic coming in, you might have some Latin coming in, some French coming in, or you might have some very special characters coming in which are not the normal special characters on the English US keyboard. Okay, because apart from the special characters which come in the English US keyboard, there are a lot of other special characters. So maybe if all of that stuff is not what you're going to be having, varchar is good. Else, it's the best example for nvarchar. You're totally right on that understanding.
Okay, thank you.
So cool, guys. I'm assuming there's no more calls, no more questions on that. So just holding on for another 2 seconds in case anyone wants to pop with another question. Yes, all good. So cheers, guys. Have a very good evening. Stay safe, be happy. Good evening, all of you. Bye-bye.